Welcome to qnawire.
Hi, so over here we're going to have the situation in which a rocket, I'm going to try to draw it as nice as possible, is going to have a constant acceleration of 24.6 meters per second squared during the first 1.5 seconds of the movement. Then it is going to go through a free fall, and we're given that the value for the mass is equal to 98.9 grams, which is the same as 0.0989 kilograms. So with this, we want to know how high does the rocket travel, considering that the mass of the fuel is much less than the value for the mass of the rocket, and we're going to ignore air resistance. So what is going to happen is that when we reach the maximum height, the movement of the rocket is going to change direction. It is going to start to fall down. That means that up until this point, the velocity is going to be equal to zero. So what we can say is that the equation of motion for the velocity as a function of time would be equal to initial velocity minus g times t, since the gravity is going to be the one responsible for this movement. Now, which initial velocity I need to consider? Well, I'm going to consider the initial velocity as the velocity when the fuel is exhausted. And as such, let's say that this is at this position. What we want to know is what is going to be the height at this point and the velocity at this point. So if we work our equations of motion, we're given that the height as a function of time is going to be equal to the initial height plus initial velocity times t plus 1/2 of acceleration times squared. This is going to be the general equation for the height. So in the first part of the movement, before the fuel runs out, I'm going to put it in green. What we are going to have is that the initial value after 1.5 seconds has passed is going to be equal to 0 plus the rocket started from a 0 initial velocity, and we're told that during this portion of the movement, the acceleration is constant at 24.6 meters per second squared. So we're going to have 1/2 of 24.6 meters per second squared multiplied by the time, which is 1.5 seconds squared. So the height at this point would be equal to 27.675 meters. At this point as well, the velocity that we're going to have would be equal to initial velocity plus acceleration times time. So in this case, the initial velocity is 0. The acceleration is going to be 24.6 meters per second squared times 1.5 seconds. So the velocity at this point is going to be equal to 36.9 meters per second. So now, this is the first portion of the movement. Now we're going to consider the free fall movement after the fuel runs out. So for that section, the y as a function of time is going to be equal to the initial height, which is going to be y at 1.5, plus initial velocity, the velocity at 1.5 times t, minus 1/2 of gravity times squared. And the velocity, as a function of time, what we want to know in this case is going to be the final time. Let's label this already on this equation. Is going to be equal to 0 when we reach the maximum height, and this would be equal to 36.9 meters per second minus gravity times t. Thus, the time that it is going to take is going to be equal to 36.9 meters per second divided by 9.81 meters per second squared, which is going to be equal to 3.7614679 seconds. Now, we can replace this final time into our equation for y, and this final time is going to be equal to y at 1.5, which is 27.675 meters, plus the velocity that we had at this moment, which is 36.9 meters per second, multiplied by this final time, minus 1/2 of 9.81 meters per second squared, multiplied by this value, squared of time. 376, 146.79 seconds, and all of this squared. So with this, the maximum height would be equal to 97.07408.083 meters. And this answer, you can cut it off with the corresponding number of significant digits required by the platform that you're employing or by your professor. And with that, it would be all. Thank you very much and have a good one.